On this episode, you'll learn how IoT and Azure SQL database go together. Join us on Data Exposed. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. Today, I'm joined by a program manager on the SQL DB team, Davide Mauri. Thanks for joining us today. How are you doing?
Great. Thank you, Anna, and nice to be back.
Awesome. We are always happy to have you here at Data Exposed. And today, we're going to talk about IoT. So what you're trying to tell me is that Azure SQL and IoT go together?
Right, exactly that. Yeah, I know it sounds strange because mainly, last year's, all the discussion were around IoT and NoSQL database, which, they are great for IoT. I'm not saying the opposite, but I just want to highlight that Azure SQL is also great for IoT. Why? I will discuss that in just a couple of minutes, but let's start with this architecture. As you can see, this is kind of a classic IoT architecture where you have things, as it shows in the picture, that are pushing data into Azure. In this case, via IoT Hub, but you could also use Event Hub as well. And then you probably want to do some transformation using function or Azure Databricks or stream processing, also to process data in real time. And then at some point, you want to land that data that has been processed in real time somewhere so that you can create an historical view of the data. You can, integrate with other tools. You can do analytics on it. And Azure SQL is really an amazing database for that because it has really a lot of features that would help IoT to get amazing performance. And I can prove you if you don't believe yet. Some of the feature I want to basically highlight that are really, really helpful for IoT are, of course, the Columnstore. I think we should discuss of Columnstore a little bit more in a dedicated video. But basically, if people are already used to with the idea of Columnstore is we are storing data on a column by column basis instead of row by row, and that helps a lot in doing near real-time analytics. But we also have Rowstore that allows, for example, to store data in an ordered fashion. So it's really perfect, for example, for doing something like time series analytics. And then we can read scale out, mean that while you are ingesting data at scale inside the database, we can create a copy of, well, not really a copy, but kind of a replication better of that database in another core, in another node, and then allow other application to access that secondary node that will not interfere with the primary one. And so you can still ingest data at scale while you are doing maybe really complex analytical query that takes minutes or even tens of minutes to be executed without affecting each other performance. So that I would say, honestly, that's amazing. And if you really, really need super high scalability, we can even have what we call memory optimized table that are memory table that doesn't use locking to preserve consistency, so they can scale to amazingly high number. And if you really need to ingest a lot of concurrent data, you can do that too. So it's really kind of encompasses all the possible need that an IoT solution may have. And of course, we also support JSON. So if your IT device is just sending JSON data to SQL, we accept happily that too, because we can manipulate JSON quite easily in Azure SQL. And all this feature allows you to create some architecture that are known as Lambda or Kappa architecture, depending on which, I would say, flavor of the architecture you want to implement. But you can rest assured that no matter which architecture you choose, Lambda or Kappa, you can easily apply it on Azure SQL.
Awesome. So when we talk about scale of IoT, sometimes we're ingesting a lot of events. Is that something Azure SQL can handle?
Yeah, sure. So, for example, one of the things I created over the last year is an example that everyone can run on their own Azure subscription. that in just a few steps is able to ingest 1 billion of rows per day, which is a huge amount of data, as you can imagine. And using a tiny SKU of hyperscale in this case, because we want to use hyperscale because we want to scale up a lot in terms of size. But we are just using 16 cores. Now, just to give you an idea, my current laptop that I'm using to record this video is using 8 cores. So with just 16 cores in the cloud, we can ingest 1 billion of rows per day, and just using 50% of the CPU resources, which means that we have enough space to handle like spikes of workload that maybe are not expected, but still we need to handle. So I would say IoT fits pretty well in Azure SQL.
Wow, I mean, it sounds pretty amazing. Can you show us something that kind of proves that?
Yes, absolutely. I'm happy you asked that to me because I have prepared basically exactly what the user and the people watching this video can also do themselves. So they can go to GitHub repository that will be linked in the description, or watch the video that is also visible here and that will be again visible, available in the description as a link, and basically create their own Kappa or Lambda architecture on Azure using the technology they want to use. In our case, we are going to use Azure SQL. And we will be able to ingest data at 600,000 messages per minute, which roughly is 1 billion of message per day, which is quite a lot. So let me just show that to you in action for real. So this is a dashboard I enable on my portal that monitors the status of my IoT solution. On the left here, you can see I have 5 simulators because the entire solution people can use from GitHub also include simulators to generate realistic IoT data in a JSON format. So I have 5 of them generating 10 megabytes per second of data, which is something like 10,000 rows per second, which on a minute-by-minute basis is 600,000 rows per second. And as you can see here, Azure SQL was able to ingest all the data that were processed upfront by Stream Analytics, because the idea of this architecture is that you're ingesting data into Event Hub or IoT Hub. You do some processing in real time using Stream Analytics or Azure Function or Databricks. In this case, we are using Stream Analytics, and then you land it on Azure SQL. Of course, you want to be sure that Azure SQL is fast enough to allow you to ingest the data without any performance issues. And as you can see, it's doing that really steadily. There is basically as much as data we are sending in, as much as data is sending out from Stream Analytics, which means it is landing nicely in Azure SQL. And as you can see here, the CPU is something around, let's say 10–50%. And then there is something, more used is the log, which is kind of expected here, but doesn't go over 30%. Except that at some point, just before this demo, I tried to do something just to show what could happen if there is a peak in number of messages to be processed. And as you can see, at some point, the number of output events reached 1.2 million per minute, so twice the time we would normally expect on average. And still, Azure SQL was able to nicely deal with it, staying within or below 70% of overall usage. And still, it recovered basically all the messages that were delayed for something that I did just on purpose, and returned it to have almost real-time ingestion of the data. And my current database is like 8 terabytes of data. Okay, let's now go and see, using Management Studio, what I can do with the data while it is being ingested at this scale. For example, I want to do some analytical query. So what I can do is, first of all, connect to my read-only node, which is this one, read-only. So this means I'm connected to the secondary node, and everything I will be doing here won't affect the performance of the primary, where data is actually being ingested. And if I check that my data is actually the current data, so the read-only node is actually kept updating in real time, This is the data, the last data I received for a specific device, and this is the current date time. So this is GMT, so 8:56 p.m. And as you can see, while I was talking, 1 minute has passed, and still the actual time is 8:57 p.m. So even the read-only node is getting data in real time. Okay, so let's now move to a much more complex query where we know it will require a lot of CPU that would potentially steal that CPU from the primary. But we are on the secondary, so we can run any complex query, even one complex like that, where we are aggregating data, actually also calculating values, extracting it from JSON, which is actually using a lot of CPU here. And no matter how much this query is going to take, it will take probably 30, 40 seconds here because we are aggregating a lot of data. There will be no impact on the primary. So the primary is still inserting data at scale at 600,000 rows per minute without any problem, because the fact that we have scaled out means that we are using one node to ingest data at scale and another one to do the processing. And this took only 13 seconds this time, and is aggregating data over the last hour. So it's also using the hot data. As we are ingesting it, we are also reading this exactly the same data, but there is no conflict between them. And this is great for IoT because it means that you can ingest data and do complex real-time analytics without having to bother about conflicting usage or a locking problem, and that will enable kind of amazing possibilities for HTAP and near real-time analytics, which are kind of the bread and butter of IoT.
Awesome. That's pretty powerful stuff. The idea that we can keep our read and write workloads separately, and also the idea that we can do things like ingest 600,000 rows per second is craziness. So thank you for showing us this today. We'll put some references so people can try this out on their own. And we'll see you next time on Data Exposed. Thank you.
Thank you so much.